session.
Yeah, good evening all. Yes, ma'am, I'll start. Yeah. Do you have any doubts in our yesterday's session? Any of you? Okay. So let me share the screen. Can you see the screen, ma'am?
Yes, ma'am.
Yes, ma'am.
Yeah. So yesterday I have explained what is a simple bar diagram and a multiple and subdivided bar diagrams. Now next one I'm going for the next one. It is a pie chart. Okay, next one is a pie chart. So here for pie chart also remember diagrammatic representation we do if the data is a categorical. If the data categorical means what? If the data is a qualitative. If the data is qualitative, then for the visualization, we go for the diagrammatic presentation. If the variable is quantitative and we want to go for the visualization, then we go for either the frequency curve, histogram, box plot, density plots, all this we do that. Okay. Now here you just see, this is the data here we are having. Now again here you what you are having? Dogs, cats, rodents, reptiles, fish. Okay, different kinds of the pets are. That means in a particular community, that particular families, what families are having which pets. Okay, this is the data has given to you. So dogs, how many families are having? 1,110 members, and cats. 987 families are having cats as a pets, and 312 families are having the rodents, and 97 families are having reptiles, and 398 are having fish. Okay, so we are talking about the pets, and these are the frequencies. So when you are having a categorical data, that means for that categorical data, we are having a frequency. Then we can go for the simple bar or a pie chart. Okay, so here I'm going for the data insert, and in that one, you can see pie. Click on it, and then you can choose any one among this. Generally, we go for this. Okay, I'm sorry. So first select the data. First select the data, go to the insert tab, and then select the pie chart and select this. So you'll be getting the graph. Okay, so this is the pie chart. So here it is telling that dogs are blue color representing dogs, red color cats, and like that. Labels are also it is showing. And suppose if you want the marks on a this one on a graph on a diagram, right click on it and add data labels. You'll be getting the values also. And how can we give the title? So just see, click on the pie chart, and then go to the layout, and then chart title above the chart, then give it pie chart. Okay, so this is a pie chart. Any doubts on this? Is it clear? And if you want to go for different colors and different designs, click on it, go to the design, and then in that select any one among this, then you can find like this. Okay, this is for your decoration purpose. That means if you want any colorful, then you will go for it. Okay, is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah. Now we are moving to the next one. Next one is what? Here. Okay, we are going for the next one. This is the data. Check this, what data here we are having. Are you able to hear my voice?
Yes, ma'am.
Yes, ma'am.
Yeah, actually, in our lane, Ganesh immersion is there today. So just now it is started. Okay. Uh, so here, this is the data. Here, what they mentioned is, this is the data. Read the question carefully. In a batch of 400 students, the height of students is given in the following table. So represent it through frequency polygon or histogram. Okay. So here, what is the meaning here? They mentioned that height of students is given in the following table. So 140 to 150, I changed the data a little bit. Why it is, I'll tell you later. So 150 to 150, 140 to 150 centimeters height. How many children, how many students are there in a class? 7 students. 150 to 160, how many students are there? 16 students. 160 to 170, 13 students. 170 to 180, 8 students. 180 to 190, 5 students. So here they are talking, leave the frequency. Frequencies are too common. Leave about the frequency. Now check the what is other variable. In the previous question, it was a pets. That means it is a categorical that you cannot measure. You have to observe it. And here, height in centimeters, which can be measurable. Okay, which can be measurable. That means height is a continuous random variable. Then in that case, we cannot go for the simple or multiple bar diagram or a pie chart. Then here we go for the graphical presentation. Then how can we go for the, remember that if the variable is quantitative, if the variable is quantitative, then we go for the histogram. Okay, then how can we do that? I'm copying this and pasting the data in columns, right click, paste special and transpose. Okay, so the data was in rows. Now I arranged in the data into the columns. Okay, then after this, what we do that you need to calculate the mid values. For the calculation of the mid values, first write the lower limits and next write the upper limits, then write the mid values. Then write the mid values. So lower limits are what? 140. Lower limit is 140. Upper limit is what? 150. And then lower limit means in the class with what number we are starting the class. And upper limit means what? In the class with what number we are ending the class. It is the upper limit. Now similarly write for the remaining also 150, 160, and next one 160, 170, and next 170, 180, and next 180, 190. Okay, then go for the mid value calculation. How can we do that? Is equal to, open the bracket, lower limit plus upper limit, close the bracket, divide it by 2. Okay, enter. Once again I'm telling you, is equal to, open the bracket, lower limit plus upper limit, close the bracket, divide it by 2. Then enter. If you are calculating one value, it's enough. Just put a cursor in the cell at a small square box, then you'll be getting a plus sign. Hold it with a right click and just drag it to the down, then you'll be getting the values of the remaining cells. Okay, then after that you just write the observation. Observations means what here? Your observations you need to write it. What is the meaning of observations? That is the frequencies whatever you are having, you need to repeat the number. Okay, in the 140 to 150 the frequency is 7. 140 to 150 mid value is 145. That means what is that? In this range we are having 7 students. So what are the heights of those students? We don't know. So we assume that all the students are having a mid value height only. Okay, so how can we do that? That is 145, 145. Just type this number 7 times. Okay, 7 times. Okay, and next 150 to 160, there are 16 students. So what is the average of this class? It is a 155. So repeat 155 16 times. 155 repeat 16 times. Okay, so 17 times have come, and then 160 to 170, the students are 13, and the mid value is what? 165. So repeat the frequency 165. Okay, repeat 165 13 times. Okay, repeat 165 13 times. Okay, and then after that 170 to 180, the frequency, the number of students are 8. So the mid value of 170 to 180 is 175. Repeat 175 8 times. Okay, repeat 175 8 times. Okay, and then after that 180 to 195 times. So repeat 185. Okay, repeat 185 5 times. Okay, so now we have arranged the data according to our requirement. Okay, once the data is arranged, everyone, did you understand how we are arranging the data? Is it clear?
Yes, ma'am. Yes, ma'am.
Yes,
Okay.
ma'am.
Now,
Yes, ma'am.
after we do that, go to the data, then data analysis. Suppose if you're not finding this data analysis option, don't worry, you can install that. So you just go to this button here. Okay, here office button, you can see the office button, click on it. Okay, just click on it. Then go for the Excel options. And in that one, go to add-ins and then click on this go and click the first two tool packs. Okay, first two tool packs. Then okay, you'll be getting a data analysis and data tab. Suppose after doing that also you did not find this data analysis. Don't worry, just restart the system. Then immediately the data analysis will be appear in the data tab. Okay, so how can we go for the histogram? Go to the data tab and data analysis. In the data analysis, you can see histogram. Okay, you can see histogram. Then, okay, it is asking what is the input range. Input range means what are the observations you typed. Okay, select all the values. If you are selecting the empty cells also, there won't be any problem. Select all the values and then it is asking bin range. Bin range is nothing but you can give the mid values. And then labels. It is asking, did you select the labels? Here I did not select any labels. I'm not having. So that's what don't mark it. Suppose if you are selecting the heading of the column also, then you need to mark the labels. Okay. Then put a cursor here and just select the output range. Put a cursor in the output range tab. Select some area where you want to see the output in an Excel sheet. Then click on this chart output. Then, okay, you'll be getting the graph. And histogram means what? It is looking like a bar only. But histogram, what is the difference in that too? Here, histogram is this, there will not be any gap between the bars. Then how can we remove it? Just any one bar, right click. On any one bar, right click. Format data series and then click on this gap. Gap width by default it is 150%. Just drag it to 0%. Or you can type here also, no problem. Then close it. This is a histogram. Okay, so this is a histogram what we require. Is it clear, everyone? Histogram is clear?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Thank you. And now, after the histogram, what they are asking, just go for the frequency curve. Okay, they are asking you to go for the frequency curve. So for the frequency curve, what do we do that? We take the mid values and the frequency. That's it. We take the mid values and the frequency. How can we do this? Copy this. Yeah. Calculate the mid values. Already I calculated. I've shown you what are the mid values. 145 and see. One thing I'll show you. Here from here mid values. If I'm copying this, will it work? Why it is coming? No, it's not a value. It is not a value. Why it is coming? Because when you are, just see, when you are putting a cursor here, see the formula bar, it is showing you the formula, not a value. But we require the value. We don't want a formula. So that's what we do that. Here, select the data and right click, paste special, click on values. Right click, paste special, click on values. Then okay. Okay, now you got a values. Got it. Now you got a values. So then what do we need to do? You need to go for the frequency curve. How can we go for the frequency curve? This mid values and the number of students. Select these two columns, go to the insert and then scatter and select the second chart subtype. This is the frequency curve of the class. Okay, 1 second. Hello, connect classroom. Yeah, connect classroom. Yeah. So I hope it is clear, everyone. Is it right? So this is the frequency curve. Okay, what is the frequency curve here? I have selected the mid values and the number of students. So after selecting this, go to the insert and then scatter and then second chart subtype. You'll be getting. And I hope you know how to give the values here, how to give the x-axis title and y-axis title. That I'm not telling you now. And now here you just see the graph is not looking that much good, right? Actually, the graph is starting from this 140, but here it is taking from 0 onwards. So this complete empty area is not showing properly. It is not looking good. So what do you need to do? You need to adjust the x-axis scale. How can we adjust? Click on this x-axis scale, right click and format axis. Okay, format axis. So here it is that minimum is auto it is taking, and here it is auto means it is starting with 0. You need to fix it and start with a 120 or 130. Maximum here what it is taking? 200. That is, let it be, don't change. And major unit, how much it is taking? Difference between the value one class to another class. 50 here, you just see that. How much it is taking? 150, 200. The width of the class it is taking 50, 50. So I can change that also. You just take a change instead of 50, 20. Then minor unit, it will take minimum 10. Don't change it. Then close it. Now can you see? I have adjusted the axis scale. Okay. Did you understand this? Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Okay. Thank you. And you need to give the, what is that? Titles of this. Select the date, select the graph, go to the layout and chart title. Above the chart, it is what? It is a histogram. Oh, I'm sorry. Here it is there. Here only you can change histogram. Okay. And then go to the layout, axis title, horizontal title below. Here, height of the student. Here write that height of the students. Height in centimeters. Okay. And then y-axis, go to the layout, axis title, vertical title, rotated title. Here what you are taking on y-axis? Number of students. Okay, so this is a way to do the histogram. Clear? Yes. And then, one second. Yeah, I'm sorry. Yeah, now after this, okay, histogram we finished, and then we are moving to the this ogive curve. What is the use of this ogive curve? That is, here you just see, select the data. What is the use of this ogive curve? I'll tell you. Let me finish this first. Okay, now the data is in rows. I need to enter the data in columns. Copy this, put a cursor, and right click, paste special, transpose. Okay, you'll be getting the data. Once the data is ready, then what do you need to do? You need to write the class. Okay, you need to write the class. Class means what is the starting value and what is the ending value in the entire data. Okay, starting value is 100 and then continue up to what? 200. Ending value is what? 200. Check it. Starting value is 100. Next is 120. Next 140, 160, 180. Last value is 200. Then write the frequency. So what is the frequency? Is equal first value. Okay, write the frequencies. Sorry, write the less than cumulative frequency. Less than cumulative frequency means, cumulative frequency means what? We'll add the values continuously. Suppose I'm having the values 1, 3, 5, 8. Cumulative frequency means what? It starts with the same first value only. Next value is what? Is equal to 1 plus 3. Okay, next one is what? Is equal to 4. Whatever you got at the previous value and this present value. 9. Then is equal to previous value plus present value. Right? So cumulative frequency means what? It will be adding continuously. Okay, so cumulative frequency. So what is the meaning of less than then? That means less than 100. How many people are there whose income is less than 100? Okay, how many people are there? How many workers are there? It is 0. Why did I take 0? Here they have given a data 100 to 120, there are 12 members. Less than 100, they did not tell anything. 100 to 120, it is there. Less than 100, nobody is there. That's what we have taken 0. And next value is equal to 120. How many members are there? Up to 120. 12 members are there. So up to 120 means less than 100 also should be included here. So add that less than cumulative frequency of 100 plus this 100 to 120. Enter. Just drag it for the remaining observations. So what is that? Less than 140. How many are there? It is up to 140, 120 to 100 to 120, 12, 120 to 140, 14. So total 26 members. Okay. So like that, here we have taken. And the last value up to 200. Daily income up to 200. How many will be there? All these people less than 200. Less than 200. How many people are there? All people comes under less than 200. So check it whether what we did is right or not. Select this number of workers, go to the home tab and right click, just click on this auto sum. You'll be getting the total. It is a 50. Check it, the last value is 50 or not. If it is 50, then our calculation is perfect. Then go for the more than cumulative frequency. So more than cumulative frequency, what it is? See, more than 100. How many are there? More than 100. All people will comes under more than 100 only. Is right. 100 to 120, 120 to 140, 140 to 160, 160 to 180, 180 to 200. That means all the workers, whatever you have in the data, that all people comes under more than 100. So we write that 50. And next one, what it is equal to more than 120. How many are there? Out of 50, if you are removing this 12, remaining will be the more than 120, right? So take this MCA first class value minus then 100 to 120 frequency. Then enter. Similarly, you just drag it for the remaining all observations. Now you just see more than 200, how many are there? It is 0. Okay, more than 200, how many are there? 0. Now select the data. Okay, after finding this more than cumulative frequency, then go select the data, go to the insert and click on the scatter, click on this button. Okay, second chart subtype. You'll be getting this. Okay, so now this is a ogive curve. What is the meaning of ogive curve? That is, you just see where the 2 points are intersecting. From that point to this, if you are drawing a line, just see. Yeah, just I'm taking one line, and from this point to, I'm just drawing one straight line. Exactly straight line. Okay, just check it here. Where is this point, this line? Where is it, where it is touching on x-axis? That point gives a median value. Okay, to show the median of the data, we go for this ogive curve. Clear? To show the median of the data, we go for this ogive curve. Understood? Yeah, just give me a minute of time. Just give me. I'm really sorry for the interruption. It was an emergency call. That's what I answered a call. Thank you. Yes. And now you just go for the next one. See, any doubts in the ogive curve? Is it clear, everyone? Can I get a reply? Is it clear, ogive curve?
Yes, ma'am. Yes,
Yes,
yes.
ma'am.
Yeah. So you please tell me, what is the purpose of ogive curve?
To find out median value.
Yes, to show the visualization of the median, we are going for this ogive curve. Okay. Yes. And now go for the next one. Just here, this is the data we are having. And for this data, they are asking calculate mean, median, mode, geometric mean, harmonic mean. How to find all these values? That is the question. Okay, this is the data. Okay, this data is what it is related to some, what is that? One teacher has given some work to the students, and how many minutes each student is taking. That data is given. Okay, for this data, they are asking you to calculate all these central tendency, measures of central tendency. Then how can we do that? Copy these values and then just see, I'm pasting. The values have not come in each cell. In one cell only we got it all the values. First you need to understand how to arrange the data, right? So select this, go to the data and then go to text to columns. Okay, go to text to columns and click on this delimited. Because why I selected this delimiter, why I'm not going for the fixed width, because here each value is separated with the comma, right? So that's what I selected this delimited. Then next, then just click on what is the delimited we are having, comma. Okay, and tab also you just take it because there is a space between the numbers. And then next, then finish. Now you just see the values have come. So just see the values have arranged here in each cell, right? So for these values, you need to find the what it is central measures of central tendency. Did you understand how we are taking up all values in different cells? Is it clear?
Yes, ma'am.
Yeah, thank you. So once this is done, then go to the, just see, calculate, just go to the functions. Okay, go to the, this functions, okay, insert functions, this function bar, click on this, okay. And then here it is telling you that, here, just see, most recently used, it is showing you. But here, just click on this small triangle, you'll be getting one drop menu. In this one, you just check it, what it is here. You just check it, statistical. Yeah, here is a statistical. Okay, we require statistical calculations, right? So then after that, you just calculate what I need, average. First one is what? Average. Click on this, then okay. It is asking what numbers you want to take. I want to take all these numbers. Okay, I want to take all these numbers. Just select that and then okay. That's it. You'll be getting the value. So what is this? This is a arithmetic mean. Okay, and next one, I'll be showing you shortcut methods also, but first you'll understand this. And then next I want to go for the geometric mean. Next I want to go for the harmonic mean. And next median. And next mode. These all calculations I have to do. Then geometric mean, how can I do that? Functions. And here statistical. In this, just now we use, so by default it will be there. And then here in that one, geometric, click on just G. You'll be find the name. Yeah, geomean. Geomean means it gives a geometric mean. Okay. And just select all the numbers. What do we have? Select all the numbers. What do we have? And then after that, click on OK. You'll be getting the geometric mean. Then harmonic mean. What is the harmonic mean? Just click on this function and then harmonic mean H. So immediately you'll find har mean, which gives the harmonic mean. Okay. Then just select the entire data, whatever you have here in place of numbers. Then okay. You'll be getting the harmonic mean. Similarly, median. Go to the functions, statistical category we require. And here what I need, median. Got it? Then okay. Select all the numbers, whatever you have. Select all the numbers, what do you have? And then okay. Got it? And then go for the mode. Then how can we go for the mode? Just again go to the function and mode M. Yeah, mode. Okay. Then select all the numbers. What do we have here? Then okay. You'll be getting the mode. Okay, this is the way to do. And instead of this, if you are want to calculate the average arithmetic mean and geometric mean, harmonic mean, we need to do this by using these functions only. If and arithmetic mean, median, mode, you may get it through the descriptive statistics. So what is the descriptive statistics? That I'll tell you after finishing the variant. This is what measures of dispersion. Okay, is this clear? And arithmetic mean you can do from here also. Just select the data, click on home tab. In this one, click on this summation button, and then one drop menu will be coming. Click on this average. So the last value will be showing you the arithmetic mean. Okay, so this is a way to find, in another way to find the arithmetic mean. Okay, yeah. Any doubt anywhere here? Is it clear?
Yes, ma'am.
No, ma'am.
Okay, thank you so much. Now after that, just go to the next question. Here what we are having here, this is the data they gave. Age of 10 girls in a class they mentioned. And for this they are asking, calculate the range, quartile deviation, standard deviation, and its coefficient. Okay, so what is the range and quartile deviation that you need to do? So take the data first. I'm just copying these values and here pasting. Can you please tell me how can I arrange these values in each cell? Can I know? Any one of you? Yes.
Ma'am, convert text to column wizard, the same thing
Yes.
which we have
Where it is
used.
there, in the menu bar, there are so many tabs are there. Which tab should I use? Okay, text to columns, that is really good. But where you find the text to columns, in which tab? Check this. Insert, page layout, formulas, data, review, view. Where did you find this among all the tabs? Text to columns. Home, insert, page layout, formulas, data, review, view.
In
In
data
which?
column, in data. In
Very good.
data, it is there, text to column.
Yes, ma'am. Yes, it is nice, ma'am. So in data tab, we are finding the text to columns. Very nice. So then here, click on this delimiter. Next, finish. Yes, you'll be getting. And here it is taking and is there. We don't want. And this 18 also it is not required. You need to do little modifications. So this is the data they give. And for this data, this is what it is the age of the students. Okay. Now for this one, they are asking you to calculate the range. So range formula is maximum value minus minimum value. Okay, maximum value minus minimum value. How can we do that? There is no inbuilt function. So first you need to calculate what is the maximum value and what is the minimum value. And then you need to calculate the range. And next after that, you need to calculate the quartile deviation. Okay, you need to calculate the quartile deviation. Okay, quartile deviation formula is what? Q3 minus Q1 by 2. Okay, Q3 minus Q1 by 2. Okay, so you need to calculate what is the third quartile and what is the first quartile. Okay, and next you need to calculate the standard deviation. So, and these are the things you need to do. And next one is you need to calculate coefficient of variation. Okay, coefficient of variation. This is what you need to find. So how can we do that? First, maximum value. How can we do? Same thing. Go to the function and here in the category, select the statistical and then here click on M. You will be finding maximum. Okay. Then here in place of number 1, you can select all the numbers. Then okay. Clear. And similarly minimum. Just go to the function, click on statistical category and here minimum. Yeah, minimum. Okay. Select all the numbers. What do you have? and then okay. Okay, and range is equal to maximum minus minimum. Enter. Maximum minus minimum. We got it. Next. Okay, did you understand range? Everyone is clear?
Yes, ma'am.
Okay, thank you. Yes. Now go for the quartile deviation. How to find the quartile? Okay, same thing. Go to the function and then click on this quartile. You will be finding, okay, it is asking array. Array means the data what you have. And then quartile, which quartile I need? Third quartile. Then, okay. Similarly for the Q1 is what? Go to the function. Then here, quartile. Then, okay. And select the array. Then, which quartile? First quartile. Then, okay, you got it. Then quartile deviation is equal to, open the bracket, Q3 minus Q1, close the bracket, divided by 2, enter. Okay, so Q3 minus Q1 by 2, you got it. Next, standard deviation, go to the function and then here, standard deviation, click on S. Yeah, STDEV means which gives the standard deviation. Then in numbers, select the numbers, what is the data you are having. Then okay, you'll be getting the value. Okay, coefficient of variation or coefficient of standard deviation. The formula is what? Mean sigma by x bar into 100. Sigma means what? Standard deviation. So first calculate what is the mean. Okay, first calculate what is the mean. How can we do that? Average of all these values. Then close the bracket, enter. Then how can we find the coefficient of variation is equal to the sigma, that is standard deviation, divided by x bar, that means mean, into 100. Clear? So this is a way to find the standard deviation. Okay, sorry, coefficient of standard deviation. Okay, so these are the measures of dispersions which we use. Is it clear, everyone?
Yes, ma'am.
Okay, thank you. And
Ma'am,
next
please
after that,
repeat this again. Ma'am, please
which one?
repeat this coefficient of variance.
Okay. Coefficient of variation formula is, I'll show you, the coefficient of variation formula is standard deviation by mean value into 100. This is the formula. Okay, standard deviation by mean value into 100. This is the formula, right? So how can we do this? This is standard deviation value, you got it here. So you need to find the mean. So I'm calculating the mean. So instead of going for this function and all the things, I'm writing the formula because I know what is the function name. So I'm writing the formula average. Open the bracket, select all the numbers, then close the bracket, enter. Okay, now substitute in the formula is equal to standard deviation divided by x bar into 100. So this is the coefficient of variation. Is it clear, ma'am?
Yes, ma'am.
Yes. Yes.
Thank you. Yes, and then we finished this. And here also the maximum and minimum value directly you can get from the home tab. Home tab, click on this summation, then you can find maximum and minimum also. Okay, you can use this method also, no problem. Okay, yes. So this question is done. And next one, they are asking you to calculate skewness and kurtosis. I told you in the last class, skewness and kurtosis mainly it is used for the finding to check whether the data follows the normality or not. Okay, whether the data follows the normal distribution or not. That for that one we go for this skewness and kurtosis. Okay, so here we are having this data. Copy this and I'm pasting here and then go to the data, text 2 columns, delimited, next, finish. We got it, right? So how can we go for the skewness? Okay, how can we go for the skewness? And next, you need to go for the kurtosis also. These are the values you need to find. Okay, you need to find for skewness and kurtosis. So you just see skewness. How can I do that? Go to the function and then in the category select the statistical and then click on S. Yeah, you can find the skew. Skew means which gives the skewness of the data. Okay, then select the numbers. Okay, then okay. So you got a minus 0.01. Okay, minus 0.01. And next, kurtosis. How can we do? Go to the functions and then go to the curt. Okay, click on K, you'll be getting a curt, then OK, which gives the kurtosis of the given data. Select the data and then OK. Okay, now there is a question. So what is this? How can we give the conclusion? What is the use of this? Here, minus 0.01 means it is approximately 0 only. Minus 1.71 means it is minus 1.71. So you just check it. If the skewness value is equal to 0, that means the data is having the bell-shaped curve. Sorry, it is having the symmetric curve. Okay, if the skewness is equal to 0, that means the data is having the skewness, sorry, what is the symmetric curve? Okay, symmetric curve. And next, kurtosis, what it is? Check it. If the kurtosis value less than 3, it is a platykurtic. If it is equal to 3, leptokurtic. If it is more than 3, if it is equal to 3, mesokurtic. If it is equal to more than 3, it is a leptokurtic. Okay, so what is the meaning of this? See, skewness will tell you what is the scatteredness of the data. Okay, and kurtosis will tell you what is the peakness of the data. Okay, what is the height of the data? You can understand. So for this data, I can say that the data doesn't follow the normality because it is a skewness. Okay, there is no skewness. It is a symmetric, but it is having a, what is that? Platykurtic. Okay, if it is mesokurtic equal to 3 or approximately 3, then I can say that the data follows the normality. Okay, yeah, is it clear, ma'am? Is it clear, ma'am?
Can you please repeat it again?
Yeah, remember, I'll tell you, if the skewness value less than 0, then we say that the data is having a negatively skewed curve. Negatively skewed curve. If the data, if the SK value is greater than 0, that means the data is having positively skewed curve. And next, if the data is equal to 0, if the data is equal to 0, that means the data is having symmetric curve. Okay, next. So this is the one thing what we need to check. And next one, if the kurtosis value, if the kurtosis value is greater than 3, sorry, less than 3, that means it is a platykurtic curve. Okay, platy curve you are having. That means platy curve means what? It is a flatter one. And next, if the kurtosis is, if the kurtosis is more than 3, that means it is a leptokurtic curve. Leptokurtic curve means what? It is very peaked one. Okay, very high peaked curve. Okay, and next, if the kurtosis is equal to 3, if the kurtosis is equal to 3, then it is a mesocurve. So mesokurtic curve. Okay, so this is a conclusion you need to remember. And you just see, when we say the data follows the normality, if the data is having approximately equal to 0 and approximately equal to 3, then or equal to 0 and equal to 3. If these two conditions satisfies, if these two conditions satisfies, then we say that our data follows a normal distribution. Is it clear, Mamna?
And ma'am, one more thing, but why only three
That is the
digit?
method, ma'am. That is a method. It is invented by the statisticians. Even I don't know that. That is a procedure. We are taking that. Even
Ma'am,
I'm
in
not.
this, here we got kurtosis minus 1.71. So this is
Yes,
not normal one, no?
yes, ma'am. It is not a normal. I told you, no, it is a platykurtic. It is the data
Okay.
doesn't follow the normality.
Okay, ma'am. And above it is minus 0 point. So it is given minus 0. So we need to consider it as 0.
Yes, ma'am. It is zero approximately. See, when you are taking on a number line, minus 0.01 means you will be getting zero immediately. That means very near or closer to the zero, right? So
Okay,
that's
ma'am.
what
Yes,
I
ma'am.
have taken it as a zero. And zero, if you are positive or negative, it doesn't mean.
Okay, ma'am.
So it is a symmetric, but not a mesokurtic. That's what we are
Okay.
telling. It is it this data, whatever I have, it doesn't follow a normal curve, normal distribution. Okay.
Okay, ma'am.
And
Yes, ma'am.
even though with this skewness and kurtosis, if you're not happy, that means if you're having a confusion, even the people are, that means, example, your supervisor asked you that, no, I'm not satisfied with these values. How you are approximating the value? It is not right. So just to use some test and check it, the data follows the normality or not. Okay. So for the normal test, we are having some tests. Example, Shapiro-Wilk test and Kolmogorov-Smirnov test, Anderson-Darling test. These are the three tests mainly we use to check whether the data follows the normal distribution or not. So based on the testing of hypothesis also, you can prove whether the data follows the normality or not. In that one, null hypothesis, we say that data follows the normal distribution. In alternative hypothesis, we take that data doesn't follow the normal distribution. Okay, so like that, we can only with the skewness and kurtosis, if you are not satisfied and you're not getting a proper conclusion, then you can go for the testing also. And visualization, through the visualization also, through the histogram and box plot also, you're not satisfied. You're not understanding what exactly. Then you can go for this testing of hypothesis also. So among all this, Anderson-Darling test is a very important test to check whether the data follows the normality or not. Is it okay, ma'am? Yes, ma'am. Okay. Then move to the next one. So you just see, now I'm entering into the probability distributions. Here, what I'm having, you just see, a machine produces 2% of defectives on an average. If four articles are chosen randomly, then what is the probability that there will be exactly two defective articles? So here what it is, they will not mention which that means by using which probability distribution you need to find the probability. You need to understand the question. So here what they're asking, a machine produces 2% defective items. Okay, on an average they are telling. Okay, and here they are asking you to find the probability that there will be exactly two defective articles. So when you are producing an item, it may be a defective and may not be a defective. That means only two possible outcomes are there. Then in that case, we can apply the binomial distribution. Is it clear? So we apply the binomial distribution. Okay, so in the binomial distribution, what we require? We require what is the n value, and what is the probability of success p value, and what is the x value. These three, if you know, then you can apply the binomial distribution. So you just check it. See, n is equal to what it is. A machine produces 2% of defectives. 2 percentage. That means it is a proportion value. Proportion value. That means it is a probability value. So P is equal to Z 2%. So is equal to 2 by 100. That is 0.02. And next, for that one, what they're asking, if four articles are chosen randomly, that means n is equal to 4. And then, what is the probability that there will be exactly two defective articles? So, x is equal to 2. Then, what do you require to find? You need to find probability of X is equal to 2. Okay, exactly two defective articles. How can we do that? Just go to the function and then in that one click on B, then you will be finding binom dist. That means it uses a binomial distribution. Then okay, okay, it is asking number of successes for what you need to find. I want to find probability of X is equal to 2, so click on 2. And trials, how many items you are taking? 4 items. And probability of success 0.02. Okay, and then cumulative, I need exactly at equal to 2 only, not less than 2 or more than 2. So that's what you can write here, false. Okay, you can write here false. And then okay, so this is the probability. What is the chance of getting a 2 defective articles among 4? It is a very less, 0.0023. Got it. Did you understand binomial distribution, ma?
Yes, ma'am.
Yeah. Okay, thank you. And now you just go for the next question. What I need. Okay, fine. So here what it is, in a shooting competition, the probability of a man hitting a target is 1.1 by 5. So probability of a man hitting a target is 1 by 5. If he shoots 5 items, then what is the probability of hitting the target at least twice? Okay, so once see, you need to check whenever you are conducting an experiment which is having suppose whether it is having a two possible outcomes or not. So when you are shooting, okay, when you are shooting, then it may hit a target or may not hit a target, right? So there are only two possible outcomes. If there are two possible outcomes, then we can apply the binomial distribution, right? And here they are asking, what is the probability of hitting a target? So probability of what you need to find, that is the success. So probability of hitting a target is how much? 1 by 5. So what it is here? Given that P is equal to 1 by 5 is equal to 1 by 5. We got a p-value. And n, what is that? If he shoots 5 items, that means n is equal to 5. Then what do you need to find? Probability of hitting the target at least twice. That means x is what? X is greater than or equal to 2. Okay, x is greater than or equal to 2. Understood? So this is what you need to find. So what we need to find here, x value, what it is? X value is more greater than or equal to 2. Okay, then probability of x greater than or equal to 2. That directly we cannot find. So probability, we know that probability of a plus probability of a complement is always 1. So this is the probability of a. Then what is the probability of a complement? X less than 2, right? X less than 2. That is, the formula for this is 1 minus probability of x less than 1. Okay, sorry, x less than 2. Okay, x less than 2. So this probability you can calculate by using this formula, more than value. We cannot calculate directly because you can get it, but it takes a lot of time and the procedure. So that's what we are going for, the another option, 1 minus probability of x less than 2. So how can we do this one? Here, calculate. Just see, calculate. First I'm calculating probability of x less than 2. Okay, probability of x less than 2. How can I do that? Go to the function and binom dist. Okay, calculate binom dist. Okay, number of successes. Okay, what is the value you need? 2. Okay, trials are how many? 5. And, oh, 1 second. Function binom dist. Okay, yeah, number of successes are how many? 2. And trials are how many? 5. And probability of success is how much? 0.2. From the data, whatever we have written, that is only. And cumulative, if it is exactly at 1 point, we take false. But here I need less than 2. Sorry, less than 2 means we need to take 1. Less than 2 means 1. And here, what it is, less than some value you need. So that's what you need to take here, true. Okay, you need to take true. Then, okay, you got this value. Probability of x less than 2, you got it. So what is the probability of x greater than 2 is equal to 1 minus this value. Enter. So probability of x more than 2 is what? At least 2 hits is equal to 0.26, 26% chance is there. Clear everyone? Is the clear binomial distribution?
Ma'am, the 0.73 is clear, but how did you get 0.26? That's not clear.
This is ma'am. C is equal to, I told you no. Greater than or equal to 2 means what? 1 minus probability of complement. This is A. Probability of A complement less than 2. Click on this, select this value, enter. Got it, ma'am?
Okay.
Yeah. So next question is, you just say that between the hours of 2 p.m. and 4 p.m., the average number of phone calls per minute coming into the switchboard of a company is 15. Okay, coming into the switchboard of a company is 15. Find the probability that during one particular minute there will be 5 phone calls. So what is that? You are concentrating on event, not on time. In 1 minute, what is the chance of getting 5 calls? Okay, getting 5 calls. So in a particular time period, you're concentrating on event. So in this case, we can apply the Poisson distribution. So how can I, in the Poisson distribution, what the values they gave? In Poisson distribution, we need to know what is the mean value and what is the x value. These two, if you know, it's enough. So here what it is, so what is the mean value on an average, how many calls they are getting? 15 calls per minute. So mean is equal to 15. And what is the x value? I need to find probability of x is equal to 5 calls. Enter. Then check the probability. So sorry, check the probability of what? Probability of x equal to 5. Okay, x equal to 5 is equal to, how can we do that? Is just go to the function and then click on this Poisson. Yes, okay. And then x is equal to what? 5. And mean is equal to how much they gave? 15. And cumulative. Can anybody tell me what should I take? Cumulative, either the true or false?
True.
No. Here what I need to find? Exactly point equal to I need. Equal to one value if you want. Then you need to take false, not true. Then okay. Got it? So this is you need to remember. Suppose if I'm asking probability of x less than 5. Okay, less than or equal to 5 or less than 6. Okay. Then now you just tell me in this one, same thing, go to the Poisson. Yeah. Okay. Now you just see here x value is what? Here I need x less than 6. So x value is what? X less than 6 means you need to take 5. If I'm taking x less than or equal to 6 means you need to take 6. Okay. And mean is equal to what? It is 15 again. And here I need less than to that number, less than or equal to that number will be calculating. So here you need to take true. Okay. Then enter. Okay. Then okay. Got it. So suppose if I need probability of x greater than 6. Okay. X greater than 6. Okay. X greater than 6. Sorry. Greater than 5. Greater than 5. How can we do that? How can we do that? Is equal to 1 minus greater than or equal to 5. This value you'll be getting. Okay. So just remember, if you require less than something, take cumulative as true. If you require exactly equal to, take cumulative as false in binomial and Poisson only. And if you require greater than or equal to or greater than means 1 minus the probability of x less than. Okay, so this is a way to do the probability. Is it clear, ma'am? Is it clear?
Yes, ma'am.
Yeah. So now you just see next question. Please you just answer this so I can understand you people are understanding me what I'm teaching. So you just see here what is that? The time taken by a person while speaking over a telephone is exponentially distributed with mean 4 minutes. Find the probability that he speaks for less than 6 minutes. So now you just tell me what is the mean value, what is the x value. I need both mean and x values I need. So you please let me know what is the mean and what is the x. Any one of you, at least one in the class? Read the question. This is a question. Read the question carefully and let me know. So what is the mean value and what is the x value? No, not even one person. Just try. If you're not getting, no problem.
Mean value is 5. X is 5.
Where
And
is the
the mean
5, ma'am?
value is
Ma'am, check it, ma'am. I highlighted the question. This question. I highlighted the question. I highlighted this question in the
less than
12th question. What is the mean value?
it is less than 6.
Mean value is less than 6, ma'am.
Mean is
Yes.
4.
No, ma'am. Check carefully. The time taken by a person while speaking over a telephone is exponentially distributed with mean 4. And find the probability that he speaks for less than 6 minutes.
Mean is 4.
Directly I gave. Is it a Poisson? I'm not talking about this data follows a Poisson distribution.
Mean is 4, ma'am.
Yes, mean is 4. Okay, mean is 4. And you need to find probability that he speaks for less than 6 minutes. Okay, now here what? They are concentrating on a time, minutes. They are concentrating on a time. Then the data follows the what is that? Exponential distribution. Remember, if you are concentrating on an event during in a particular time period, we go for Poisson distribution. And next, if you are concentrating on time, then we go for exponential distribution. So here they have given mean is equal to, how much it is? 4. And then what is the probability we need to find? Probability of less than x less than 6 minutes. Okay, so x value is how much here? Less than 6 minutes. Okay, now here how can we find this? Probability of x less than 6 minutes is equal to, how can we do that? Go to the function and then here click on E, exponential distribution. Okay, then here it is asking what is the x. X is nothing but here I need to find 6. Don't write less than 6, 6 only. In cumulative you need to mention true or false. Less than means we take true. Okay, less than means we take true. And lambda, lambda means what? Here we take a mean value. Okay, one by mean. Lambda is nothing but what? 1 by mean. Okay, 1 by mean. Mean is equal to what? 4. Clear? So mean, what is the lambda? It is a 1 by mean. Then okay. Okay, then okay. Okay, just click. This is the probability. 1 second. Hello. In class lo unna. So is it clear, everyone? Is it clear? Exponential distribution. Can I get a reply?
Yes, ma'am.
Okay, thank you. And next one, go for the next question. So just see the next question, 13th question. The mean weight of 500 students in a certain college is 151.16 and the standard deviation is 15 pounds. Assuming that the weights are normally distributed, find how many students weighed more than 160 pounds. More than 160 pounds. They are asking more than 160 pounds, and they told that the data follows the normal distribution. Then how can we do it? That is, just see here they mention mean is equal to 151.16 and what is the standard deviation? 15. So standard deviation is equal to 15. And then we need to find probability of x more than 160 pounds. Okay, more than 160 pounds. So more than means I told that directly we cannot calculate. We will be calculating by using a formula 1 minus probability of x less than some number, whatever you have less than 60. Then how can we do this one? First calculate probability of x less than 160. How can we do that? Just go to the function normal n, click on n. So you can see norm dist. Okay. It is asking what is the x value? Okay, x, what I need? 160. And then mean is equal to how much? 151.16 and standard deviation it is 15. Cumulative we require less than, so write that true. Then okay, you'll be getting the value. Then how can we get this? The probability of x more than 160 is equal to 1 minus x less than 160. You'll be getting the formula. So what is that? You'll be getting the answer 27.782. They're talking about number of students. Okay, number of students. So number of students means how many out of 500. How many students height is more than 160? Sorry, weight is more than 160 pounds. So is equal to 500 into probability of more than 160 is how much? 0.277. Then select the cell, you'll be getting. So 138.9 means round off the number, just decrease the decimal. So what it is? 139. So among 150 students, sorry, how many? Among 500 students, 139 students are having more than 160 pounds as weight. Okay, more than 160 pounds of weight. Is it clear, ma'am? Normal distribution is clear? Can I get a reply?
Ma'am.
Okay. Now, after this, they have given this data. Okay, next, they have given this data. And now they have given marks in math and marks in stat. Now they are asking you to find correlation. They are asking you to find correlation. Whether is there any relation between these two or not, you need to check. If it is there, how much it is there, you need to say. So how can we do that? Just go to the same thing, function, and then under the category statistical, and here click on correlation. Okay, just see correlation. Okay, it is asking what is array 1? Select the first row, and array 2, select only the values. Okay, then okay, it will be showing you there is what? Minus 40.9. Okay, minus 40.9 means minus 41% relation. Okay, there is a negative relation. So what it is? It is a less than 0.5. That means there is a low degree negative correlation between marks in math and marks in stat. And suppose if you want to show this data in graphical presentation, copy this, paste the values, and you'll be getting in columns. Then go to the insert and click on scatter. Click the first one. This is a way to find the scatter. That means this is a way to check the negative correlation. Clear. This is a way to check the correlation. Understood? So this is a visualization. That's it. Yeah. So any doubt in this? Is it clear, ma'am? Correlation.
Yes, ma'am.
Is it clear?
Yes, ma'am.
Yeah. So now just check it after the next one. Here they have given this data. Yeah. They have given us sales and production of a particular commodity. So sales they have given in lakhs and production they have given in quintals. Okay. Now you need to check here what they are asking. Find out what is that, estimate the sales of a company if the production is 300. Okay. Sales of the company if the production is 300 quintals. Okay. This is what they are asking. Now you just tell me you need to predict something. If you are going for prediction, apply the regression analysis. Okay, apply the regression analysis. Clear? So how can we do that then? To apply the regression analysis, you need to know what is the dependent variable and what is the independent variable. So you just let me know what is the dependent variable in these two based on the question. Yes? What they are asking you to find based on what? What is the dependent variable and what is the independent variable? If there is wrong also, no problem. You just answer. Anything. See, here we are having two variables. Yes, ma'am.
Production is a dependent variable.
Production is a dependent variable. Okay. Sales is an independent variable, right?
Yes,
No,
ma'am.
ma'am. You just check it. No. Here, what do you require to find? They are asking sales is equal to what? Okay, based on what? Production is equal to 300. That means based on the production, you are finding a sales. What you require to find, that variable is a dependent variable. Based on what you are finding, that is called the independent variable. Production is an independent variable. Clear, everyone? So you need to check the question very carefully what they are asking you to do. Okay, so now sales you need to find. So how can we do it? Just go to arrange the data. Okay, let it be. So just go to the data and then data analysis, and here you can see the regression. Okay, then okay. Once again, I'm telling you, go to the, just see, go to the data analysis, and this one regression, then okay. Input y range. Y means it is what? Y means it is a dependent variable. X means independent variable. And remember, the data must be in columns. Then only it will do the calculation. So copy these values and then just go to the pay special transpose. Okay, now we got a data. Then now go to the data tab, data analysis, regression. Okay, input y range. Input y range means y means dependent variable. Dependent variable is sales. I have selected the heading also. You just see, I selected the heading also. And input x range. Select the this X range, production values, labels. Did you select the headings? Yes, I selected. So click on labels. If you don't select, then don't click on it. Click on output range. Put a cursor here. Where you want to see the output, select some area. Then okay. Okay, here you need to check. And here you need to see what is the R square value. Whenever you are going for the calculation of regression, check it. R square value must be more than zero point 0.5. Okay, if it is more than 0.75, then it is good. 0.5 also somewhat can be acceptable, but not that means not that much. That means we cannot go for it. Okay, if there is no option, then we will be accepted. Okay, so how can, if suppose you may get it out here, R square value is 0.42, then how can we increase the R square value? That is By increasing the sample size, you can increase the R square value. Okay, that is one thing you need to remember. So in the output, what do you get it? Among all this, you need to check what is the R square value. It should be more than 0.5. So more than 0.7 is 0.75 is the preferable. Okay, and next, after that, whatever the model you are fitting, whether the fitted model is correct or not, how can you identify the significance value? It should be less than 0.05. Okay, significance value must be less than 0.05. Then our model is that means our fitted model is a good model. This is the second point what you need to check. Okay, and then after that you need to write the regression equation. So what is the regression equation? Y is equal to a plus bx. Okay, so what is that? A is called intercept. Okay, a is called intercept. B is called coefficient of, okay, coefficient of independent variable. Okay, coefficient of independent variable. Then what is the equation? Here y is nothing but what? Here y is a dependent variable. Yeah. And what is the x then? X is a independent variable. Yeah, x is an independent variable. So how can we write the equation then? Here the equation for the given data is sales is equal to, we know that dependent variable is the sales, independent variable is the production. So sales is equal to intercept. You need to check the coefficient column. You need to check this whatever I have highlighted. Check the coefficient column. And in this one, intercept, how much it is? 15.43. So write that 15.439. That means 44 plus Bx. B means what? Production coefficient of the independent variable, that is production. So 0.09, 0.09 into production. Okay, this is the equation what we require. Okay, what we require in the analysis. Okay, now the question is what they're asking, what is the sales if the production is 300? How can I do that? Sales is equal to, sales is equal to, now you just write that is equal to intercept plus production coefficient, that is B, into production. How much it is? 300. Enter. So what it is? If the production is 300 quintals, then sales will be 43.06 lakhs. Okay. So this is the conclusion. Is it clear? Is regression clear? Is regression clear? Am I audible? Am I audible?
Ma'am, your the calculation was little fast. We couldn't get it.
Yes, ma'am.
Ma'am, you're audible, but calculation was little fast. We couldn't read what was
Can you,
there in that coefficient.
I did not understand. Can you speak a little louder? Here, a lot of disturbance is there.
Ma'am, the whatever terms you're using, now coefficient and everything, that
Yes,
is
ma'am.
not clear. From where did you get it? Interception and production
Okay,
coefficient, something.
okay. Yeah, that I'll tell you, ma'am. See, regression equation. This is a general model, general equation of the regression. This is a regression. This is called the regression model. Regression equation is y is equal to a plus bx. If there is only one dependent, one independent variable. Okay, this is a regression equation. Y is equal to a plus bx. Okay, so in this one, what is the meaning of all the terms here? Y represent the dependent variable, X represent the independent variable, A represent the intercept, and B represent the coefficient of independent variable, that is coefficient of X. So from this table, how can we write the equation? So we know that y is equal to sales I wrote is equal to. Here A means what? I told you intercept in the coefficient column. Intercept value, here you can see that. Intercept value is how much? 15.4398. So I have taken 15.44 plus production. So coefficient of x. X is the production, right? So here B is nothing but what? This is 0.092 into X is what? Production. This is the equation. Is it clear, ma'am? Is it clear, ma'am, now?
Yes, ma'am. Yes, ma'am.
Okay, thank you. So now you just see, I'll be showing you the another question. Now you please let me know how to do this. So here you just tell me what is the dependent variable and what is the independent variable. Yeah, please let me know what is the dependent variable and what is the independent variable. Read the question
Ma'am,
carefully.
production is
Production is
dependent.
very nice. Production is dependent. Very nice, ma'am. Next, independent is what? Independent
Sales.
variable. Sales is the
Sales.
independent variable. Yes, nice, ma'am. So here what is that? If sales is equal something, you require to find what is the production, right? So that's what production is the dependent variable, sales is the independent variable. So now here you just go to the again same procedure, data, data analysis, regression. Okay, clear everything. Yeah. Now you just see. Now here in this data, let me know y range means which one should I consider? Y means what? Y means what? Is it the independent variable or a dependent variable?
Dependent.
Dependent
Why?
variable.
Yes, Y is a dependent variable. So now with this data, which one should I take? Which data should I take in place of Y? Production or sales?
Production. Production.
Yes, nice. And next, X is nothing but remaining column, sales. Okay, labels. Yes, I selected the headings. Click on labels. Put a cursor where you want to see the output. I want to see the output here. Then, okay, you'll be getting this. So I told you, first you need to check the R square. For this data, what is the regression model you are fitting? It is not a good model. But how to fit, I'm telling you. So how can you improve your model? By increasing the sample size. Suppose if there is no possibility of increasing the sample size. So other than this regression, there are so many other methods are also there. You need to use those methods. Okay, that all comes under the machine learning algorithms. Okay, so if I explain that, you may not understand. So later we'll see that. Okay, so yeah, I told you that R square value is more than 0.75. It is preferable. More than zero point 0.5. Okay, somewhat we accept. And this ANOVA significance value, this value always must be less than 0.05. Then only our model is a good model. And next you need to check the coefficients. Okay, then next you need to check coefficients. Okay, then what will be the equation here? Here, what it is? Y is the production. Y is the production is equal to A. A is the intercept value 49.14 plus I rounded to the two decimals. Okay, plus B. B is coefficient of independent variable 4.61 into sales. This is the equation. Okay, this is the equation of the regression. Okay, now they ask you to calculate the production. Okay, calculate the production. How can we do that? Is equal to intercept plus this sales into sales is equal to how much I told? 100 lakhs. Then what will be the production? Production will be 510.471 quintals. Okay. Is it clear, ma'am? Regression. It is the most important one. Is it clear?
Yes, ma'am, it is clear, but is it like suppose if we want to test, it should have one dependent variable and one independent variable, then only it will be applicable to test regression analysis.
Yes, ma'am. And ma'am, if
And
you're having
what
more
about
than
sample size, ma'am?
sample size, there is no restriction. Whatever you want to have, you can, ma'am. There is no
Okay,
restriction in it. And
okay,
one
ma'am.
more. In the data, always we cannot find only the one dependent and one independent, right? If you're having
Yes,
more than one independent, okay. So here what I'm
yes, ma'am.
taking that wages also I'm taking. Wages also I'm taking. So my sales are depending on the production of the item and number of hours it is working. Okay, number of hours the machine is working. Okay, here I'm taking 10 hours per day and 15 hours, 20 hours, 25 hours, 12 hours, 13 hours, and 15 hours. Like this, you are having another column. Example, I'm telling you. Okay, example, I'm having this. Now, in this case, what it is, I need to find sales is equal to what? Based on what? Based on production is equal to, for example, 350 quintals and number of hours is equal to 18. Okay, what I'm asking, so sales is equal to something you require to find based on two independent variables, right? So in this case, we use a multiple regression. Okay, in this case, we use multiple regression. So how can we do it? Same thing. Go to the data, then data analysis, regression. Okay. So generally what we do that dependent variable means y value. I need to find sales. Independent variable means what you are taking. In the previous example, you took only one, but you take two independent variables simultaneously at a stretch. Okay, together you just select the two independent variables, then click on labels and output range where I want to see the output that I will change. Yeah, here I want to see the output, then okay. Now you just see here what it is, you are having this. So intercept and production and number of hours, this one. So remember, another way of increasing the R square is increasing the number of independent variables. Clear. And how can you write the equation here? Y is equal to A intercept, it is common, plus B1 x1 plus B2 x2. What is the meaning of this B1 x1? X1 means first independent variable, x2 means second independent variable, B1, B2 are its coefficients. So what is the equation can be written then? That is sales is equal to what I can write? Intercept 20.24 plus B1. B1, X1 is a production. So production intercept coefficient is what? 0.083. So 0.083 into. So what it is? X1 production and plus what it is? Number of B2 is what? Number of hours. Open the bracket minus 0.185 into close the bracket into number of hours. Okay, this is the equation what we require for the data. And how can we predict this? How can we predict then? Sales is equal to. So what did I ask you? Is equal to intercept plus production coefficient into how much production I told you. Example, it is a 350 quintals plus number of hours. If it is number of hours, coefficient is this into how many hours I asked you? 18 hours. So what will be the sales? 45 lakhs. What will be the sales? It is a 45 lakhs. Is it clear, ma'am? This is called the multiple regression. Why are we calling it as a multiple regression? More than one independent variable we are having. Yeah, is it clear, ma'am?
Yes, ma'am.
Okay, thank you. And this is a very important concept, ma'am. Yeah, now move to the next question. So this is, we finished this one. Till here, what we had, we finished. Okay, and now 16, 17, I'll not explain. If time permits, I'll explain. If because that are not that much important. 7, 18 onwards, I'm starting. If time permits, I'll explain these two also. Okay, That is some extra questions only, no problem. And now here you just see what they're asking. A random sample of 10 boys had the following IQs 70, 120, and so on up to 100. Does this data support the assumption of population mean IQ of 100? They are concentrating what? They are concentrating on mean value. They are asking you to test this mean value. Okay, test this mean value. Clear? So what do you need to write here? First you just write what they have given. Population mean. So population mean, how much they gave? It is 100. Okay, population mean is equal to 100. They gave this. And next one, they gave a data. What it is? IQ of 10 students. So IQ of 10 students. What it is? Select these values and paste here and just go to the data, text to 2 columns. Yeah, delimiter, then finish, then okay. Yeah, you got the values. So IQ values you had. Now you just see 3, 6, 9, one more. Yeah, so 10 students IQ values are there. Now what you need to test? Whether the population mean is 100 IQ or not, you need to check. So what I'm writing, H naught, null hypothesis, H naught, null hypothesis, what they're asking, does this data support the assumption of population mean IQ of 100? So write that, population mean IQ is 100. And next, H1, what it is? Population mean IQ is not 100. Okay, so this is what we are having, right? Now here, they're concentrating on the mean value. So appropriate test is t-test for. So t-test for what? Here in the t-test we are having single sample and the 2 samples also. Here it is for only 1 sample is there. So we go for t-test for single mean. Okay, appropriate test we have written. Then you need to go for the test statistic. Test statistic formula is x bar minus mu by sigma by root n. I'll type my equation, I'll show you. So what it is? Equation P cal is equal to x bar. Here I'm writing the formula. X bar minus mu. X bar minus mu. There is a mu by sigma by root n. So sigma means here where it is. Okay, sigma by root n. So what is the root n here? So this is the formula. This is the formula of what? T test for single mean. So what is the formula? T cal is equal to x bar minus mu by sigma by root n. Okay, sigma by root n. Okay, so not sigma, I'm sorry, s by root n. We go for this. Okay, s by root n. So what is the x bar represent? X bar tells that sample mean. What does the mu represent? Population mean. S represent standard deviation of sample. N is equal to number of observations. Okay, this is the formula. Okay, which you need to remember. There is no inbuilt function for t-test for single mean. Okay, so just write that. Here you just write T. Here, what is that? What are the values they gave? Population mean is equal to 100. Now, sample mean. Okay, next one is what? Sample mean is equal to, what it is equal to average. Average of, select all the observations and then close the bracket, enter. So sample mean we got it, standard deviation, sample standard deviation. How can we do that? Here you just go for the same thing, function and STDEV. Or directly if you know the formula, type the formula STDEV, standard deviation. open the bracket and select all the observations, close the bracket, enter. Okay, we got this. And n is equal to how many observations they told? 10. Then what is the tcal formula? Tcal is equal to tcal is equal to x bar. That means sample mean minus mu. That means population mean. Close the bracket, divided by, open the bracket, sigma, sorry, s. It is the standard deviation by root n, sqrt of n. Then close the bracket, then enter. So what is the tcal value? Minus 0.022. Tcal value is how much? Minus 0.022. Okay. And after this, see, you need to give the conclusion whether accept H naught or reject H naught. That you need to check. How can we do that? You need to calculate the p value. Okay, you need to calculate the p value. So how can we calculate the p value? For that one, you just use a t dist is equal to t dist. Open the bracket. X is nothing but the calculated value here. What do you have? Take a positive number only, 0.0228. Okay, comma. X is nothing but the test statistics. What you got it? And degrees of freedom. Degrees of freedom is n minus 1. N is equal to 10. It is a 9. 10 minus 1, 9. Tails. So it here you are telling that IQ is 100 and IQ is not 100. It may be greater or it may be less. So that's what we are taking. Tails is equal to 2. Close the bracket, then enter. So this is a p-value. Okay, this is a p-value. Now how can we give the conclusion? You just check it. If the p-value is more than 0.05, then accept H naught. Remember, if the p-value is more than 0.05, we accept H naught. Clear? So accept H naught means what? For this data, population mean IQ is 100 among all the children. Okay, this is the conclusion. Is it clear, ma? Is it clear? Can I get a reply?
Yes, ma'am. Yes, ma'am. It is clear.
Thank you, ma'am. Yeah, thank you, ma'am. And now you just go for the next question. So just see, this is the data we are having. Okay, let me this one first. Okay, just see here we are having this data. So two types of drugs were used on 5 and 7 patients for reducing their weights. Okay, so drug A used on 5 people, drug B used on 7 people. The different people both are. Okay, now you need to check, is there a significant difference in the efficiency of two drugs? That is, you need to check. Efficiency of two drugs, that is, you need to check. So how can we do that? Paste the values. Now you just see, here you just write that H naught. Okay, H naught. Somebody asked me yesterday, always will it be a positive statement only? I told that it is not possible. So tomorrow while doing the case study analysis, I'll tell you that. Okay, so what is that? H naught. H naught is what? That is both the drugs are equally efficient. Okay, and what is the H1? Both the drugs are not equally efficient. Okay, what did they assume? Yeah, difference in efficiency. Yes. So here not equally means again it is a two-tailed only. Now, how can we do that? Here just copy this data and paste it in columns. That is space special transpose. Okay. Yes. Now we got the data. And for this data, just here there is an inbuilt function you can do directly. So go to the data analysis, and here t test for 2 means assuming equal variances. Mention that assuming equal variances. Then okay. Okay. Variable 1 range select the drug A values, don't select empty area, select the drug A values and variable 2, put a cursor and select the drug B values and hypothesis difference 0. Both equally under H naught, what we are assuming, both are equally efficient. So drug A is equal to drug B. That means difference is what then? Drug A minus drug B is equal to 0. Okay, labels. Yes, I selected the labels also while taking the data and click on this output range, put a cursor and then place, select some area. Okay. So this is the result what we got it. So from this one, what do you understand? That is inner data. What it is? Inner data in a drug A mean average of this. Average of first drug A people it is 12. Average of drug B it is 11. And the variance values they gave observations. In the first set, we are having 5 observations. In the second drug, we are having 7 observations. And pooled variance. That means if you're clubbing all the values here together, what is the variance you'll be getting? That is a pooled variance. And next, degrees of freedom is nothing but number of independent variables or number of parameters estimated in the data in the formula that is will be taken. So degrees of freedom. And next one, T statistic is a T calculated value. And now this is a probability value for this T cal and critical value for this and probability value is also this. Okay, so this is the data you are having. So among all this, how we can give the conclusion? That is the most important one. So here our data is what? Two-tailed data. So take the p-value. So your p-value is also again you are having two values. One-tail p-value, two-tail p-value. So here our alternative hypothesis not equal. It is a two-tailed. So p-value is how much it is? 0.479. Okay, 0.479 and check it. If the p-value, what it is more than 0.05. So more than 0.05 means what? If the p-value more than 0.05, then accept H naught. Okay, then accept H naught. Okay, clear everyone? Accept H naught means what? Both the drugs are equally efficient in reducing the weights of the people. Is it clear, ma'am?
Yes, ma'am.
Yes.
Yes. Yes. And now go for the next question. Yeah, just take this. Next question. Now you just see, here this is the data they gave. What data they gave? Here they have given. Yeah, so here what they gave. Before advertisement, see, they are, 1 minute, read the question. The sales data of a production before and after advertisement are given below. Can the advertisement can be judged as effective? That means advertisement is effective or not, you need to check. Okay, so for that, what they have taken? They have taken a 8 shops in a particular community. 8 shops they have taken, and from those shops only, you collected before the advertisement what are the sales of an item, and after the advertisement, what are the sales of an item have taken. Okay, so here what is that? Before and after you are mentioning. Okay, before advertisement and after advertisement, and that is also taken from the same people. Then we can apply the paid t-test. Now there is a question. Now there is a question for you. If I'm having 1 to 8 shops, I collected before advertisement data, and 9 to 16, okay, here not different shops I have taken. Different shops I have taken for the after advertisement. Then can I apply the paid t-test? Yes. See, I told you, if there is a same shop before and after, if you are collecting, that means from one shop, you are collecting the data 2 times, before some advertisements and after some advertisements. Okay, then In that case, we go for paid t-test. Okay, suppose if the variable, that means if the data is collected from two different groups of people, then in that case, we go for the t-test for two means. Understood? The difference is clear? The difference is clear? Yes?
Yes,
Okay.
ma'am.
Yeah. So now you just see, this is the data. How can we do that? Go to the data analysis, and here you can see that paid t-test. T-test for paid to sample for means. Okay. Variable 1 range before advertisement. Variable 2 range after advertisement. Hypothesize difference 0. Click on labels. Click on output range. Then select some area. Then okay. Now this is a conclusion. Here, what is the p-value? P-value is more than 0.53. Okay, p-value is, what is that? P-value is equal to more 0.53, which is more than 0.05. That means accept H naught. Accept H naught means, what do we say that? That means we can assume the advertisement is effective. Okay, I'm sorry. Let me write the hypothesis for this. I'm sorry. Yeah. So H naught means what, ma'am, everyone? H naught means there is no difference. There is no difference in the sales before and after the advertisement. Then what is the statement I can pass here? The advertisement is not effective. Did you understand? One ma'am asked me, is the hypothesis always be a positive null hypothesis? See, what did I take here? Advertisement is not effective. It is a negative statement. So based on the test, you need to decide what statement can be taken. So advertisement is not effective. Why did I take not effective? Because if there is no change in the before and after sales, then definitely we assume that the data, that means advertisement is not effective. There is no difference. That means advertisement is not effective. H1, what do we write that? Advertisement is effective. Advertisement is effective. Clear? So now here you just see p-value is more than 0.05. This p-value we have taken. Okay, this p-value we have taken, so which is more than 0.05. Then what do we do that? Accept H naught. That means in that particular community, advertisement is not effective. How many times you are giving your advertisement of your shop or a particular item? It is not showing any impact on increasing the sales of the product. Is it clear? Is it clear, everyone? Yes? Is it clear? Can I get a reply? Can I get a reply? Okay, thank you. Yes, and next one. You just see, I'll explain this question and I'll stop a session because chi-square, if I explain, you may not understand because this is little calculations required. I'll tell you tomorrow and after that I'll start a case study. Okay, so the last question of today's session, this one. Here what they're asking, two samples are drawn from two normal populations. Test whether the two samples have the same variances. You need to check whether the two samples are having the same variances or not. So how can we do that? That is, yeah, so this is the data they gave. So for this one, we need to check both the samples are having the same variance or not. So two samples and you are testing the variance, we go for the F test. It is very simple. Go to the data analysis and check it here, F test. Okay, F test for two sample variances. Then, okay, variable one range. Select the first data, don't select the empty area, select only the values. And variable 2 range, select the values. Labels, yes, I selected the heading. Output range, put a cursor here, select some area. Then okay, you'll be getting this. So in this one, just check that What is the p-value? P-value is 0.31. P-value is what? 0.31, which is also more than 0.05. That means what do we say that? Accept H naught. Accept H naught means what? Both the samples have come from the same population. There is no difference in variances. No difference in variance means what? Both the samples have come from the same population. Okay, H1 is what? There is a difference. That means both the samples are having a different variations. That means have come from the different populations. Okay, so accept H naught means what? We say that both the samples have come from the same population. This is a conclusion. Is it clear, everyone? Is it clear?
Yes, ma'am.
Yeah. So, if you have any doubts, feel free to ask me and don't miss tomorrow's session. It will be very helpful for your any case studies or any analysis or in your any paperwork. Okay, so don't miss tomorrow's session and I'll be explaining one case study definitely and another case study if time permits, I'll explain. Otherwise, in the same way, you can do that. Okay, so I'm stopping the screen. Yeah. So I hope if you have any doubt, you can ask me. Yeah. Jyoti ma'am, are you there?
Yes, ma'am.
Yeah.
Yes,
So,
ma'am. I'm here.
okay, ma'am. Thank you. So if anybody is having any doubts, if they're not asking here, no problem, ma'am. You collect the questions from them and you can text me. In tomorrow's session, I can answer those questions. If they are not
Okay,
asking
ma'am.
here. Yeah.
Okay,
So
ma'am.
thank you, ma'am. Yeah.
Thank you,
Any
ma'am.
more doubts?